In an era where scientific advancement often hinges on collaboration, Western Reserve University CWRU and University Hospitals are pioneering a new initiative aimed at fostering team science. Recently, these institutions jointly awarded 5 research teams with Collaborative Science Pilot Awards, each receiving $50,000 to support innovative studies in various critical health fields. This program not only provides financial backing but also aspires to bridge the gap between clinical practice and scientific research, promoting interdisciplinary collaboration that is essential for tackling complex medical challenges. Stan Gerson, dean at CWRU School of Medicine, emphasized the importance of collaboration in scientific endeavors, stating, "Collaboration and mentorship are essential for the advancement of science innovation in medicine." This sentiment echoes the program's goal of pairing early career researchers with seasoned investigators, thereby nurturing talent and facilitating problem solving through shared expertise. The awards, which stem from a strategic partnership that began 2 years ago, reflect a growing recognition of the necessity for collaborative approaches in scientific research. This year's selected projects showcase a diverse range of research areas, underscoring the multifaceted nature of modern healthcare challenges. One notable initiative focuses on developing a large-scale magnetic resonance fingerprinting (MRF) database aimed at improving neuroimaging techniques. Led by Chatra Badv and Mark Griswold, this project seeks to create a comprehensive resource that will enhance diagnostic accuracy in neurological diseases through innovative imaging technologies. Another significant project aims to tackle keratoconus, a progressive eye condition that can lead to vision loss. Sudha Iyengar and Loretta Saksatka-Flynn are working on the development of a genetic test for early detection of this condition, which typically manifests in young adulthood. Their research could lead to earlier interventions that significantly improve patient outcomes. Alzheimer's disease. A growing global health concern is the focus of another funded project led by Stephen Fink and Andrew Piper. Their team is investigating the role of a specific protein 15-PGDH as a therapeutic target. By analyzing gene expression in the brains of Alzheimer's models, they aim to uncover new pathways for treatment that could potentially change the landscape of dementia care. The initiative also extends to Autism Spectrum Disorder (ASD), with a project exploring the potential of probiotics to alleviate gastrointestinal symptoms often associated with the condition. Led by Mahmood Ghanem and his team, this research addresses a critical aspect of ASD that has been overlooked, demonstrating the breadth of the collaborative effort. Lastly, a project examining the role of bradykinin in malaria-related cerebral edema is set to continue its second year of funding under the leadership of Alvin Schmeier and James Kazura. Their previous findings have indicated promising pathways for developing new therapeutic options to combat this severe complication of malaria. These collaborative science pilot awards are indicative of a broader trend in the research community where interdisciplinary collaboration is becoming paramount for addressing the pressing health challenges of our time. Daniel Simon, president of Academic and External Affairs at remarked on the initiative's purpose: "The joint effort is to bring physician scientists and scientists together to solve unmet clinical needs." This collaborative spirit not only enhances the quality of research but also increases the potential for securing major external funding in the future. As the landscape of medical research continues to evolve, the successes of these projects may pave the way for enhanced diagnostics, innovative therapies, and improved patient care. With the initial funding in place, researchers are poised to make significant strides in their respective fields, and the collaborative framework established by CWRU and promises to yield impactful findings that could resonate throughout the scientific community. Looking ahead, the focus on collaborative research will likely become increasingly critical in addressing the multifaceted health issues confronting society today. In a remarkable convergence of scientific innovation and public health strategy, several key developments have emerged recently in the life sciences and vaccine technology sectors. These advancements not only highlight the growing importance of research and development in combating global health challenges but also outline a future where cutting-edge technologies may significantly enhance our ability to respond to diseases. The European Molecular Biology Organization (EMBO) has announced the awarding of installation grants to 10 promising life scientists across Europe. These grants, which provide €50,000 annually for 5 years, aim to bolster early career researchers as they establish their laboratories and push the boundaries of life sciences in several participating nations, including Croatia, Greece, and Poland. EMBO Director Fiona Watt emphasized the initiative's role in fostering a vibrant research community, stating EMBO installation grants offer flexible funding, extensive networking opportunities, and practical support for life scientists pursuing ambitious research projects. This year's cohort includes a diverse group of scientists, with half being female, and a mix of research projects that span various crucial topics from insect resistance to extreme heat to the mechanistic studies of human co-translational quality control. In parallel, Aldevron has unveiled its next-generation alchemy cell-free DNA technology, a significant breakthrough aimed at accelerating mRNA development projects. This innovative technology reduces the manufacturing time for research-grade linear DNA by over 50%, thus expediting the production process for mRNA synthesis. Venkata Indurthi, Aldevron's chief scientific officer, remarked that the technology not only enhances production efficiency but also ensures higher purity of DNA by minimizing the presence of host cell proteins and other impurities. With a future cGMP offering expected in 2025 for clinical applications, alchemy is positioned to play a pivotal role in the next wave of genomic medicine, providing researchers with a reliable foundation for their mRNA synthesis projects. On the public health front, the U.S. government has committed $590 million to fast-track vaccine development against the avian influenza virus, underscoring the urgency of addressing potential pandemics. This funding is part of a broader initiative to enhance vaccine preparedness in the face of an inevitable influenza pandemic, as articulated by health officials. The investment aims to bolster research and development efforts, ensuring that vaccines can be rapidly adapted and deployed as needed. Moreover, Micron Biomedical has made headlines by winning a $2 million prize from the Biomedical Advanced Research and Development Authority (BARDA) as part of its Patch Forward competition. This prize supports the development of needle-free vaccine delivery systems, which could revolutionize how vaccines are administered. Micron's technology utilizes dissolvable microarray buttons that deliver vaccines painlessly into the skin, offering significant advantages such as ease of use and the elimination of cold storage requirements. Stephen Damon, CEO of Micron Biomedical, highlighted the potential impact of this technology in increasing vaccination rates globally, particularly in underserved populations. As these developments unfold, the intersection of innovative research funding, groundbreaking technologies, and strategic public health investments paints a promising picture for the future of medicine. The continued emphasis on collaboration among scientific communities, government agencies, and private enterprises will be crucial in addressing the health challenges that lie ahead. With the next application deadline for EMBO installation grants approaching on April 15, 2025, and Aldevron's alchemy technology paving the way for faster mRNA development, it is clear that the landscape of life sciences is evolving rapidly, with the potential to significantly improve global health outcomes in the years to come. In a groundbreaking study published in Scientific Reports, researchers have unveiled a novel approach using persistent homology pH to identify key genes involved in cancer networks. This innovative methodology addresses a long-standing challenge in cancer genomics, distinguishing between driver mutations, which are crucial to oncogenesis, and passenger mutations, which occur randomly and do not contribute to cancer progression. The research, led by Rodrigo Enrique Ramos and his team at the University of São Paulo, integrates mutation data from 6 cancer types and focuses on 3 essential biological functions: DNA repair, chromatin organization, and programmed cell death. Cancer research has evolved significantly due to advancements in genomic sequencing and public databases facilitating the identification of cancer-related genes. However, the distinction between driver and passenger mutations remains complex. Driver mutations are linked to cancer development, while passenger mutations result from random genetic changes. The challenge lies in accurately identifying these drivers. as they present potential targets for targeted therapies and personalized medicine. The study highlights the limitations of traditional network science measures, which often focus on individual nodes and edges, potentially overlooking the intricate high-dimensional interactions within cancer networks. A method from algebraic topology offers a fresh perspective by capturing higher-order structures that provide deeper insights into gene interactions. The researchers constructed cancer consensus networks (CCNs) based on pathway networks and systematically analyzed the impact of gene removal on topological voids beta-2 structures within these networks. The results were revealing. Only known driver genes in cancer-associated genes significantly affected the beta-2 structures, while passenger genes did not. Importantly, the study indicates that traditional centrality measures alone are insufficient to fully characterize impactful genes. By combining higher-order topological analysis with conventional network metrics, the researchers enhanced the precision of distinguishing between driver genes and passenger mutations. Only known driver genes in cancer-associated genes influence these structures, while passenger genes do not, noted Ramos. This finding underscores the critical role of known driver genes in the context of higher-order structures within cancer networks, emphasizing the need for innovative approaches to gene characterization. The research incorporated mutation data from the Cancer Genome Atlas (TCGA) and utilized Reactome's super pathways to construct CCNs that reflect biological functions relevant to cancer. The study also explored the application of pH in analyzing protein-protein interaction networks, further solidifying its utility in cancer research. The implications of this study extend beyond theoretical advancements; they offer practical insights into cancer treatment. By improving the identification of driver genes, researchers can potentially enhance the development of targeted therapies, ultimately leading to better patient outcomes. Furthermore, the integration of cultural and communication aspects into cancer care is highlighted by concurrent initiatives at institutions like St. Jude Children's Research Hospital, points to a holistic approach to cancer treatment that considers both scientific and cultural dimensions. Looking ahead, the research team recognizes the need for further exploration into higher dimensional structures within cancer networks. As they continue to refine their methodologies, their work stands to contribute significantly to the understanding of cancer biology and the development of innovative treatment strategies. The study serves as a testament to the power of combining advanced computational techniques with biological insights, paving the way for future breakthroughs in the fight against cancer. As we venture further into 2025, the landscape of artificial intelligence, AI, and data science continues to evolve at an unprecedented pace, promising to reshape industries and improve everyday lives. Recent analyses reveal 5 key trends that are poised to define the future of AI and data science, highlighting the intricate interplay between technology culture and business leadership. A report published by MIT Sloan Management Review identifies the rising prominence of agentic AI, which refers to AI systems capable of performing tasks independently. As technology leaders anticipate a surge in these autonomous systems, they recognize the necessity of focusing on specific applications of generative AI. Thomas H. Davenport, a leading expert in the field, emphasized, "There will be generative AI bots that will do people's bidding on specific content creation tasks, but it will require more than one of these agentic AI tools to do something significant." This indicates a future where collaboration between these tools could enhance productivity in various sectors. However, the realization of this potential hinges on the ability of organizations to measure the effectiveness of their generative AI initiatives. Davenport pointed out that many firms are yet to accurately assess productivity gains or understand how their workforce is reallocating time saved through automation. If companies are really going to see and profit from Gen AI, they're going to need to measure and experiment to see the benefits, he stated, underscoring the importance of robust metrics in harnessing AI's full potential. The cultural shift towards becoming a data-driven organization also emerged as a critical challenge. Survey results indicated that 92% of respondents view cultural and change management issues as the primary barriers to adopting data and AI-driven practices. Randy Bean, another expert involved in the report, articulated that while organizations have made strides in this area, generative AI alone is not enough to make organizations and cultures data-driven. This suggests that technology adoption must be accompanied by a comprehensive cultural transformation to realize its benefits fully. Additionally, the conversation around unstructured data is gaining traction. The rise of generative AI has emphasized the need for better handling of unstructured data, which remains a labor-intensive task. Davenport remarked, "Even when we reach a point where we can load vast amounts of our internal documents into a GenAI prompt window, there will still be a need for considerable human curation of the data." This highlights a persistent requirement for human oversight in the age of AI. As organizations grapple with these evolving dynamics, the question of governance, specifically who should oversee AI and data initiatives, remains contentious. Experts suggest that the role of chief data and AI officers should pivot towards business leadership, ensuring that technological innovations align with organizational goals. Davenport advocates for supertech leaders who can integrate various tech roles under a cohesive strategy, indicating a move towards more integrated leadership structures in data and AI governance. In a parallel discussion, experts from a panel organized by Science and Technology Daily explored the societal implications of AI advancements. During the event titled Tech with Heart, AI for Good, the panelists emphasized AI's transformative potential across diverse sectors, particularly in healthcare and legal services. Chen Ying, an associate researcher at the Institute of Automation of the Chinese Academy of Sciences, illustrated how AI is bridging the gap in medical access between urban and rural areas, stating, "By utilizing smart technology, the experience and knowledge of seasoned doctors can now be shared more widely." Furthermore, AI's integration into traditional Chinese medicine (TCM) was noted for its potential to enhance preventive healthcare by leveraging data analysis for early detection of health issues. Professor Gao Shaolin highlighted that AI could democratize access to TCM expertise, thereby making preventative care more accessible and effective. The legal sector is also witnessing significant changes due to AI innovations. AI tools are now being employed to streamline legal processes, enhance legal education, and reduce the burden on legal professionals by automating routine tasks. This evolution is poised to create new career paths, merging technology with legal expertise to address complex challenges. Looking ahead, both Davenport and Bean foresee a future where interdisciplinary collaboration will be vital for AI's advancement. As industries converge, professionals from various fields, ranging from computer science to the humanities, will need to work together to drive innovation. This collaboration will not only foster technological advancements but also create new opportunities for talent across sectors. In summary, the trends outlined for 2025 reveal a multifaceted evolution in AI and data science, marked by the rise of agentic AI, the necessity for cultural shifts, and the ongoing importance of unstructured data management. As organizations navigate these complexities, they must prioritize measurement, governance, and interdisciplinary collaboration to fully leverage AI's transformative potential. The journey ahead promises to be as challenging as it is exciting, paving the way for innovations that could significantly enhance the quality of life and reshape our understanding of technology's role in society. In a significant leap towards harnessing the power of nuclear fusion, China's experimental advanced superconducting tokamak East, also known as the artificial sun, has set a new world record by maintaining a steady loop of superhot plasma for an impressive 1,066 seconds. This achievement, reported on January 20, 2025, represents a monumental step in humanity's quest for clean and virtually limitless energy, as it more than doubles the reactor's previous record of 403 seconds. Nuclear fusion, the process that powers the sun, involves fusing light atomic nuclei into heavier ones, releasing vast amounts of energy in the process. Unlike traditional nuclear fission, which generates long-lived radioactive waste, fusion promises a cleaner alternative with minimal environmental impact. However, researchers have faced numerous challenges in achieving a self-sustaining fusion reaction, a milestone that scientists have been pursuing for over 7 decades. The East reactor's latest record showcases its magnetic confinement capabilities, crucial for maintaining the high temperatures and pressures necessary for fusion. As Song Yun Tao, director of the Institute of Plasma Physics at the Chinese Academy of Sciences, stated, a fusion device must achieve stable operation at high efficiency for thousands of seconds to enable the self-sustaining circulation of plasma, which is critical for the continuous power generation of future fusion plants. While this remarkable achievement does not immediately translate into a functional fusion power plant, it lays the groundwork for future developments in the field. Other fusion reactors, including those in the United States and Europe, continue to explore various methodologies, with many still consuming more energy than they produce. For instance, the U.S. National Ignition Facility achieved a brief moment of ignition in 2022 but still faced challenges in overall energy output. In parallel, the University of Seville's SMART project has also made strides in nuclear fusion technology by successfully generating its first plasma. The SMART reactor, notable for its spherical design and negative triangularity plasma shape, aims to demonstrate efficient plasma confinement for future compact fusion reactors. Principal investigator Manuel Garcia Munoz emphasized the significance of this milestone, stating, the SMART approach is a potential game-changer with attractive fusion performance and power handling for future compact fusion reactors. The advancements of both the East reactor and the SMART project signify the growing momentum in the global pursuit of nuclear fusion. With ongoing international collaborations, including efforts under the International Thermonuclear Experimental Reactor ITER program, researchers are increasingly optimistic about the prospects of bringing fusion energy to practical use. As more countries invest in this technology, the potential for sustainable energy solutions becomes increasingly tangible. Looking ahead, the fusion community remains cautiously optimistic. While there is no immediate timeline for operational fusion power plants, the achievements of East and SMART signal a promising future for nuclear fusion research. With continued international cooperation and scientific innovation, the dream of achieving clean, abundant energy through fusion may one day become a reality, transforming the global energy landscape forever.